This video is about load balancing using PCC, which is per connection classifier. Effectively, what we're going to do is I'm going to go through how we can use the PCC. Is actually what we're going to use to mark those the traffic, and then based on those marks, that's what is going to be used in the routing table to route each way. So we're basing this example of having two internet connections. We're going to say that both internet connections are different speeds. So the primary is going to be 30 meg and the secondary is going to be 10 meg. We're going to set up those Mangle rules, which is going to be what's going to basically, we're going to start by specifying anything going out of one port is marked with a certain routing mark, and out the other one is the other one. And then we're going to match that LAN traffic, and we're going to also specify how we want our traffic divided up. So we're going to use the PCCs in a almost like a metric based on our ratio, based on our speeds, because we've got one more than the other. So we're going to send 2/3 of it out of one, and then 1/3 out of the other. Now I'll go into PCC in a bit more detail. Effectively, it's basically like I mentioned, marking those packets, and it allows us then to distribute. It marks those packets. Sorry, it marks those connections. So the connection, as a connection is established from a LAN destined for a WAN IP, for a destination IP. That connection then gets marked and routed a certain way in terms of the return traffic as well. So we can do that by things like source. So I initiate a connection from one IP, it's going to go out of a particular interface, and then all my traffic will go that way. We can do it based on destination, we can do it based on source port, we can do source address and port. And then the one I'm going to do is port and address can be different each time. So it's the more random approach to hopefully spread that load across. So I've got two devices connected to my router, so hopefully I can generate enough traffic off both and then simulate. And I've also got my PRTG server running on one of them, which is monitoring the two interfaces. So we can then hopefully see on a graphical a bit clearer how it's sharing that traffic across both links. But yeah, enough talk, let's get onto it. So here we have my router. This one again is my virtual one, which I've used for some of my other queuing videos. Two connections. One's a dynamic IP address, which I'm getting on Ether 1. The secondary is a PPPoE, which I'm getting on Ether 2. Both again dynamic. And then we have my LAN here on my bridge, which I've just called user 1. We'll start by looking at the routing table. So what I've done is I've already added 2 additional routing tables. We can get rid of backup because that's not needed anymore. RSP1 and RSP2. Just make sure you have this fib ticked, so these routes are injected into the main routing table. And then when we jump on our routing table, you can see I just have these 2 gateways. Again, both dynamic. One has a lower weight, and this is just for a very high level basic failover scenario. So this interface has to actually go down for this one to come into use. But I've done several other videos about failovers, so check those out if you want to do something a bit more robust and granular. But for now, what we're going to do is we're going to add our 2 additional routes into here using our different routing tables. So we're going to pick RSP1 is going to be our first one. So that gateway is going to be 101.1, sorry, and RSP1. So anything in that routing table or with that routing mark, as will be our traffic, will be routed out of that. And then we'll do the same for our PPPoE 164.7.1, and again that's going to be RSP2. I will just show you a little trick I do as well, because we're getting the DHCP address gateway. This was in one of my other videos as well, which again I'll put a link to the description. This is just a little script that runs every time it gets an IP address. It's going to take that IP address of the gateway it gets, and it's going to apply it to the rule, or sorry, the route that is named what I've called ISP1, as you can see just there. It can't be done with a PPPoE, unfortunately. We could do other scripts that would, run with a scheduler, but that's getting a bit too far with this video. But it's just a little way, because basically, if this was our ISP or whatever was to change our IP address and gateway because we're on a dynamic service, obviously that route would fail because it wouldn't be able to reach its next hop. So this is just a way of every time it renews its IP address, it will then populate that address. But again, check that other video out where I go into a bit more detail for that, but I thought I'd just show you that while it's there. Okay, let's just do inline comments. There we go. Okay, so that's my routing table all set up. Now what we need to do is actually force traffic to go either way. So now we're going to go to IP firewall. Here we have, so natting, obviously I'm masquerading out between both options, so any traffic goes out of either one of those gets masqueraded, which is what you need to do for multiple links. Now Mangle rules, let's make sure we get all of these set, because there's quite a few to do. First ones we're going to do, everything's going to be in the pre-routing train first and foremost, but this one is going to be the return traffic first of all. So anything coming in from Ether 1 with a connection state of new and with no mark set, so basically a clear packet with nothing marked on it, we're going to then give it a mark, a connection mark, a mark connection, and we're going to call it ISP1 underscore con. Okay, and then we're just going to copy that and do the same for ISP2, and that's coming in from PPPoE. Okay, I'll just add what we added. Yeah, there we go. New connection mark, no mark. Okay, now we're going to do we're going to use those marks for every time this leaves the router. So we're going to do it on the output chain. We're going to now match on those ones we've just set. It's ISP. Actually, make sure I don't type it wrong. So ISP connection 1. This time we're going to use that connection mark and we're going to turn it into a marking of the routing. And we're going to actually, now we can see these are populated by those 3 routing tables I've got. So first route, anything coming in to Ether 1 will mark its connection, and then that connection then will be by the second row will be marking its packet, routing, sorry, and that will determine which routing table it uses. Hopefully that's clear enough. Let's just set the second one up. This one's 2, action 2. Oh, whoops, didn't copy it, I just overwrote it. Or pass through 1, and this was connection 1. Okay, yeah, let's make sure I've got them all here, present and correct. Right. Okay, now we're going to do our user traffic. Now for this one, because I mentioned before we have 2 connections, one is 10 and one is 30. So there's lots of different ways of doing this, and it's quite a complex way it does it, but from a simplistic way I kind of view it. If we were to do, we had 2 identical connections of 50 meg, for example, then that's basically equal. So we can do 2 connections and 2 to 2 basically, or 1 to 1 if you narrow it down. So then we can do, for this time, what I'm going to do is I'm going to do 3 to 1 for the first one and 2 to 3 for the second one. So I'll show you what I mean. So let's get into it. So in interface is coming from user 1. This is going to be anything that's not currently marked. So connection no mark, and it's a new connection. We're going to go to our extra first of all, and we're going to specify that it's not local traffic, so it's forwarding traffic. And then under advanced, our per connection classifier, as we can see here, which is the whole thing in this video. And now I'm going to do this both addresses and ports. You could do the source address, and then it would mean every client would, if you had a large network, and it didn't really matter if you could you'd equally basically share your clients across connections across the two links. But as I've only got 2 today, it's a bit hard to demonstrate otherwise, so I'm going to go for this both addresses and ports. Now this is what I meant. So this is where I'm going to split it into three lots of connections, and we're going to give 2 to the first one and 1 to the smaller one. So we start off with 0. So this is the first one. We go to action, we go mark connection, and then we're going to give it that same ISP1 connection mark. Okay, still with me? Okay, let's apply that and copy it, and we'll do the same again. So we're going to do another one for the same connection, but we're going to increment this by 1. And then action, we're still going to mark it with that one. And then copy that again. Now this time we're going to do one for the second link, so the ISP2. We're just going to give this one 2. So it doesn't start on 1, it starts on 0. Yeah, check out MikroTik's website for all this. It goes into huge amounts of detail. If you do want more information around this, I'm happy to do a separate video, but it's quite like I said, it's in depth and lots of maths and stuff. So we could really, I guess, if we could then say there's 3 lots of 10 in 30, and then there's 1 10, so we could do it 4 and then give 3 to the one and then the 4th to the other connection, if that makes sense. But anyway, let's not get too carried away here. This works pretty well. So there we go, we got our 3 there, and as you can see, I've included this column so we can see. So 0, it's because I did that one first tonight. That's fine. So that's 2 is number 2, 0 and 1. Okay, let's go. Now we need to, again, like we did for this one here, we're going to mark use that connection mark to mark our routing. So use pre-routing again, coming in from user 1 with that connection mark. Going to go action and mark routing, and then ISP1. Okay, and then we just copy that and do the same for ISP2. So basically the way it goes is you mark a connection, and then you use that mark of a connection to then mark the routing. So the PCC doesn't actually do any of the load balancing. You're just seeing that connection coming in under certain criteria, and you're slapping that connection mark onto it. And then when the second rule sees it, it says, hang on, this is a connection mark. I want to put this routing on you, which basically says use this routing table. And that determines the actual which path it takes. Okay, so you always go mark connection, mark route, mark connection, mark route. Okay, so let's do a bit of testing. So as I mentioned before, I've got PRTG here set up. So let's PPPoE and my user 1 data. So this is my higher link. Let's bring up the live graph. Again, if you want to know how to use PRTG and set up your MikroTik with that, check out the video I've done about doing that. I was doing it based on uniquely identifying queues, but the same logic applies to setting up the SNMP. It's much simpler just to do it with an SNMP traffic sensor. Okay, so now we're going to go ahead and generate some traffic. Let's bring up some. Okay. Let's do some downloads. Okay, wait for that to start. Let's go to YouTube. Oh, that looks like an interesting video. Check that out. This is fun. Let's load some more. Okay, so we're loading a few there. Okay, is that downloading? That is downloading. Okay, let's jump on a MikroTik. Look at our interfaces. So we've got data going out both links, 1 and 2. So 2 is what my PPPoE is using. Okay, and now let's jump on my. I mentioned I had 2 hosts. Let's jump on the second one. Okay. Okay, we'll do some download some stuff, and we'll look at some stuff on YouTube. Okay, it started. Again, let's look at this guy. Oh, just want a few videos just to run. Okay, close, minimize that. So both of these machines are on the same network. As you can see, my LAN is producing sort of 19 meg now. Okay, we can try and let's do a speed test as well. Okay, it's obviously using the maximum it can do. One point of note is a lot of people think load balancing is something to do with bonding. So you buy 2 50 meg connections, you get 100 meg. It doesn't work like that. You are splitting your connections across the 2. So you'll only ever have the capacity of 50 meg. Sorry, you'll only have the speed of 50 meg, but you'll have the capacity effectively of 100 meg. So I've seen it before where someone said, "Oh, I brought an extra connection, so I should be getting this amount." But when I do a speed test, it's like, well, no, you're never going to get that amount unless you bond it. This isn't a bonded service. This is load balancing. Okay, bonding's it requires you to have end-to-end somewhere for that connection to pass over and be re-bonded or joined back together on the other side. So that isn't that. So just so you clarify, I've got 10 and 30. I'm not getting 40. Okay. So now we can jump back on our. Here we go. Right. So Ether 1 is my 30 meg connection. We're getting not maxing out there yet. What's going on here? We're not getting anything here at the moment. Oh, there we go. Refresh. There we go. So although I've got 10 meg here, we're not using the full 10 meg. And although I've got 30, oh, there we go. We're now spiking up at 30. But it's probably fairly equal that it's sharing that load. It's preferring this side, if that makes sense. Although once this goes above 10 meg on the other one, obviously it would max out. So hopefully that makes sense. So as you can see, we've now got data going across both of them, which is what we want to see. It's hard to see here because it goes so quickly that in kilobits. But we can clearly see on our LAN, which is also coming in on this Ether 3. So these match. So we're coming in about 20 meg, and then that's being divvied up between these 2. Okay, so hopefully that gives you a bit of clarity. Go back on this. If we just had a 1-for-1 connection, and we wanted to load balance equally across both, we would just do this as 2/0 and 2/1. Okay, so remember that the second value always starts on 0 and then increments up. And then the first one is how many of these you're going to have. So we've got 3 here. If we're going to have 2 because we've got equal links. If, for example, we had a much greater distance, we would then need to work out that ratio and make these rules accordingly, so we could effectively have these individual streams. So we'll use the first one, then the second one, and then once it's maxed out. In fact, if we look at our connections, expand this and sort it by these ones, you can see we could count these up if we wanted to. And then as you can see, there's lots of ISP1 connections, and then there's probably, say, so 2/3 ISP1 and then 1/3 ISP2. So you can see that's how it's divvying up. And these are live connections between, so we've got one machine here on 251 and the other one's on 253, as you can see there. But they're different ports and different, it's obviously access, and this is probably one of the downloads, maybe. And then you'll see all the YouTube in there as well. So yeah, hopefully that's gives you some idea of how to set it all up. Again, also with a failover, yeah, it won't automatically just use a secondary one if the first one goes down. We need to actually tell it to make that unavailable effectively. So again, that's where you could then run that failover stuff outside of this as well. So we could do some recursive routing or using the script method as I've shown in other videos. But again, they're all links in the description. Please check them out. They're there's lots of different ways of doing it. MikroTik is has so many features, but that can also be its downfall if you don't know how to use them. If they get it's very powerful, has so many different ways of doing something that people may look at it and go, oh, what do I want to use this for? It's too it's too much. I like this product because it's simple. That's fair enough. You want to use that product, use that product. But if you're someone that wants to have that control and you like to understand how everything's working in the finite, like I do, which is the reason I always make these videos, because that's why I like MikroTik. So but otherwise, please comment if you've got any questions. If you want any content made, please let me know. If not, please like and subscribe, and keep watching. Thank you.